So this question says the expression 1/3 x squared minus 2 can be rewritten as 1/3 times x minus k times x plus k, right? So these two things are equivalent. Where k is a positive constant, what is the value of k, right? So what are we going to fill in for k? So because these two things are equals, like how do I get them to have the same format? I see that they both have the 1/3 here. But then this then has like a product of binomials multiplied by that 1/3. Whereas this here is just a difference of two terms, right? X squared minus 2. So there's something fundamentally different about these questions that we have to notice. And that is that whatever this is, right? So if I were to expand this x minus k times x plus k, it'd be x squared minus k squared. And then I'd have 1/3 in front of that. And actually this 1/3, because these guys are in parentheses, this 1/3 would impact both of these. So it'd be 1/3 like this, which means you can write it as 1/3 x squared minus 1/3 k squared. But the format of the left-hand side is not like that, right? There's no parentheses, which means really I just have a 1/3 x squared. Those two terms are attached. And then I have a minus 2, right? So I think that's really the key to answering this question, or knowing how to approach this question, is in looking at the difference between the x squared minus 2 here and how it relates to 1/3 versus the set of, the product of these binomials in parentheses here and how they relate to 1/3. Because if I truly want the left side to look like the right side, I need to figure out, well, how do I rewrite this left side so that I know what goes in parentheses here, right? In order to get out a 1/3 x squared minus 2. So let's think about that. So I would need this first term to be x squared, right? Because when I distribute 1/3 times x squared, I get 1/3 x squared. But now what would I need this second term to be? I know it's going to be a minus sign, but what needs to go here? And the way I should think about that is, well, what would I need to have in this position that I have in green so that when I multiply 1/3 by it, I simply get a minus 2. And that number would have to be 6. Okay, so what I'm saying is 1/3 parentheses x squared minus 6 is equivalent to 1/3 x squared minus 2. They're equivalent. And it's important that I write it this way because now at least I have the same structure that I have here with the set of parentheses here. Again, realizing that this 1/3 is not just a coefficient, it actually gets distributed across whatever's to the right side of it. So now that I have that correct, let me erase this and just write that right below. So this will be 1/3 x squared minus 6 equals 1/3 x minus k times x plus k. So now it's just, well, how do I expand this difference of two terms here, this x squared minus 6? Well, this proves to me, or the format of this proves to me that I'm dealing with a difference of two squares. And which means this also needs to be a difference of two squares. So when I expand this, this is going to be x squared minus square root 6 squared. It's kind of how I'm going to think of it. So that it can break down into x minus root 6 times x plus square root 6. And just for a little bit of review, the difference of two squares, right? We're used to seeing things like x squared minus 4. A good way to think of x squared minus 4, however, so we can truly see the nature of it being the difference of two squares, is to think of it as x squared minus 2 squared, right? And then that is how we get, in factored form, x minus 2 times x plus 2. So in essence, this x squared minus 6 is of this format, but we want to transition it into this format. So we need to understand what this is, the equivalent of this format is for our x squared minus 6, and that's where this step comes in, right? The square root of 6 squared is just 6, but now at least we can see this as being the difference of two squares, right? Now we see it that way, and that's what allows us to then write out this way. So that being said, our minus root 6 and our plus root 6 are in the same positions as our minus k and our positive k. This question just wants us to figure out the value of k, and k therefore must be choice D, which is square root 6. A completely other way to solve this, let's just completely start from scratch here. Another way to think about this is plugging in answers, right? So I'm saying I have 1/3 x squared minus 2. I want it to be the same as 1/3 x minus k times x plus k. All of these answer choices represent k values. So I can use the strategy plug in answers to solve this. So if I try choice A, for instance, that's to say that k is equal to 2. And I can just plug it in here and see, well, what happens when k is equal to 2? I'd have 1/3 x minus 2 times x plus 2. X minus 2 times x plus 2 is x squared minus 4. So I'd have 1/3, and don't forget this is still in parentheses, x squared minus 4, and then, this is not in parentheses here, so I'd have to get rid of those parentheses. So I'd distribute my 1/3 across, and I'd have 1/3 x squared minus 4/3, which of course is not the same as 1/3 x squared minus 2. So that's why choice A is gone. We do the same thing for choice B, where we say k is equal to 6. So I'd have 1/3 x minus 6 times x plus 6. That gives me 1/3 x squared minus 36. I distribute the 1/3 across. I get 1/3 x squared minus 12, which again is not congruent to 1/3 x squared minus 2, and that will be the reason why B is gone. We try choice C. 1/3, again, this is k equals square root 2. So I have 1/3 x minus root 2 times x plus square root 2. And this becomes 1/3 x squared minus 2 once I FOIL that. And again, I need to distribute this, again, because the parentheses really are the key to answering this question. Understanding those parentheses will still be there. This 1/3 impacts everything to the right side of it, not just the one thing next to it here. So then when I distribute by 1/3, I have 1/3 x squared minus 2/3, which of course is not the same as 1/3 x squared minus 2. So that's why C is gone. And then lastly, we know this is the right answer from doing it using our other method, but maybe this is a better method to have started off with in the first place. We say, well, hey, if k is equal to the square root of 6, that means I have 1/3 x minus root 6 times x plus root 6. And therefore, I would have 1/3 parentheses x squared minus 6. And then when I distribute the 1/3, I get 1/3 x squared minus 2, which is exactly what I was looking for all along. And again, that's why choice D is the best answer.